everyone. Are you trying to decide between using Kafka consumer groups or Kafka streams in your architecture? You're not alone. These two approaches both consume from Kafka topics, but they solve different problems. In this video, we will break it all down using a simple diagram. From how each works internally to when you should use which. Our goal is to understand the mechanics, data flow, state handling, and best use cases for both consumer groups and Kafka streams. Let's use this diagram as our reference. At the heart of both approaches is the Kafka topic, a distributed up-and-only log that stores events like customer orders, logins, sensor data. This topic is portioned for scalability, and from here two paths emerge, one to a Kafka consumer group and another to a Kafka streams application. First, let's look at Kafka consumer groups. This model is used when you want to distribute the workload of consuming Kafka messages across multiple instances of your application. Each consumer in the group is assigned one or more partitions, ensuring that no two consumers read the same data. This makes the system horizontally scalable and ideal for stateless processing. You can easily increase throughput by just adding more consumers. Each consumer processes events independently. It might validate them, transform them, or enrich them with external data. The result is typically pushed to an external system, a database, a data warehouse, or a downstream microservice. A major part of this setup is offset management. Kafka keeps track of how far each consumer has read, but you can also control this manually. This is helpful when you're implementing at least once or exactly once processing guarantees in your system. And since you can use any language, Java, Python, Go, Node.js, Kafka consumer groups are very flexible. They are perfect for microservices, log processing, and simple ETL pipelines. Here are some common examples. Reading Kafka events and inserting them into PostgreSQL or MongoDB database, validating customer transactions and calling payment APIs, moving logs or metrics from Kafka into an analytics backend like Elasticsearch. These jobs are typically stateless, and all state, if any, is externalized into a database or cache. Now let's shift to the Kafka streams path. Unlike consumer groups, Kafka streams is a Java library for building real-time distributed stream processing applications within your code base. It consumes records from Kafka, but instead of sending them to external systems right away, It processes them through a chain of operations like filters, maps, joins, and aggregations, all inside the application itself. Kafka Streams builds a topology, a directed graph of transformations. In our diagram, you can see it begins with a filter followed by a mapping function and then a join with user profile data. But the real magic happens when state is involved. Kafka Streams maintain local state stores backed by RocksDB to hold things like counters, recent events, or aggregates. This state is automatically backed up to Kafka using changelog topics, which allows full recovery in case of failure. Kafka Streams also makes time a first-class citizen. You can define sliding or tumbling windows, enabling things like counting logins per user per 5-minute window, aggregating sales totals per region per hour, handling out of order events and late arrivals. You don't have to manually schedule or poll. The stream triggers computations based on event timestamps and stream progress. Another strength is exactly once processing. With proper configuration, Kafka ensures that every record is processed once, even if the app crashes or restarts. This eliminates duplicate writes and keeps aggregates accurate. And since Kafka Streams app are just regular Java services, you can deploy them anywhere, Kubernetes, Docker, or even directly on a VM without needing a separate cluster like Flink or Spark. Kafka Streams is ideal when you need to detect fraud by aggregating activity over time, enrich live transactions streams with user metadata, maintain real-time views, dashboards, or alerting pipelines, perform complex joins and windowed analytics directly in your app. Let's do a quick head-to-head comparison to solidify the differences. For language support, Kafka consumers groups uses any languages like Java, Python, Go, etc. But with Kafka Streams, they only use Java or Scala. For the processing model, Kafka consumer groups are stateless, but Kafka Streams are stateful with RocksDB. For output destination, Kafka consumer groups outputs to external system, whereas Kafka Streams outputs to Kafka topics. With offset management, Kafka consumer groups offer manual or auto. Kafka Streams offer automatic only. When it comes to windowing or aggregation, Kafka consumer groups offer external only, whereas Kafka Streams offer built-in support. When it comes to deployment, Kafka consumer groups are deployed as separate service or function, whereas Kafka streams are deployed as embedded Java app, no extra cluster. Common use cases for Kafka consumer groups or ETL microservices. For Kafka streams, common use cases are real time analytics and enrichment. As you can see, Kafka Streams provides a lot more functionality out of the box, but only if you need it. So, which one should you use? You can use Kafka consumer groups if you're building microservices or ETL jobs, or if you need to write to external systems, or if you want multi language support, or if your processing is stateless or offloads state externally. You can decide to use Kafka streams if you need real time processing with joins, aggregates, or windows. If you want everything from ingestion to transformation to state within one application. If you're building in Java or Scala and need exactly one's guarantees. To wrap up, Kafka consumer groups are excellent for stateless, horizontally scalable workloads. Kafka Streams gives you real-time stateful stream processing with built-in reliability and fault tolerance. Both are powerful and they can even be used together depending on your architecture. If this breakdown helped you understand the trade offs, give the video a like and a subscribe for more practical deep dives into distributed systems and cloud data architectures.